Good morning, students. Welcome to this first class of this third term. So today we are going to talk about hand tools generally used in the workshop. So the tools generally used for working with materials are classified into four categories. So the first category is called the measuring and marking out tools, which is used to transfer measurements and to cut before cutting out the materials accurately to the size we need. So there is also the driving tools, which is used to drive materials or elements into the material itself. Then there are the holding tools, which is used to keep tight the materials while working with it. And the cutting tools, which are used to cut out the tools accurately. So first of all, let us see about the measuring and marking out tools. So measuring and marking out is aimed to transfer required dimension and shape on a material. So before cutting, we have to measure the accurate distances we need or mark out the shape, required shape we need on the material before cutting. So it is important to select the appropriate tools accordingly to the task to be accomplished and the material we are working on. So there are different types of measuring tools adapted to the materials we are using. So there are measuring tools used for metals, measuring tools used for wood or plastics. So during the measuring and marking process, it is always good to practice, to have good practices, okay, not to damage the material. First of all, we avoid parallax error by placing eye perpendicularly. So what is parallax error? Whenever we have to measure, for example, here we have a ruler measuring a small object. So the dimension here is 2 centimeters. But if we place our eye in the wrong position, we have a wrong reading. So we read 1.9 centimeter because we are looking in the wrong direction. If we look in the other direction, it will read 2.4 centimeter. So we have to place our eye onto perpendicularly to the material to have the exact reading. So when we look at the wrong position, from a wrong position, this is called parallax error. Okay, so this is always good to avoid, to have the exact reading when measuring a material. So also avoid error. So next, we avoid end errors for accurate measurement. So what is an end error? For example, when we measure an object, some rulers, the zero doesn't start from the edge itself. It starts a bit further. So make sure to start from the zero when reading from the zero, okay, to the end of the object. So when we measure the object from the edge itself, it makes an end error. Okay, this is to be avoided. So next, clamp works securely using scrap wood. So some materials have to be clamped, so that is to be held firmly before starting to measure, because if it moves, the reading might not be good. Okay, so clamp your work securely using scrap wood before uh, measuring the material. So some examples of measuring tools. Okay, so the most used tool to measure in a workshop is a measuring tape. Okay, so a measuring tape is available in different lengths and scales. So generally we measure in millimeter and centimeter. Inch is not so used today nowadays. We mostly use millimeter and centimeter to measure the materials in the workshop. Okay, sometimes in meters also. It is used to measure long dimensions. So measuring tapes is used to measure long dimensions. So we have measuring tapes measuring 3 meters and up to 5 meters in the workshop. So as you can see here, though, so there are some measuring tapes which measure in inch and others in centimeters and millimeters. So we will be using this side instead, okay, to measure in centimeters and millimeters. So it is clipped on the edge on the material, and we can measure the length that we want. So the measuring tape is used onto wood, metals, and plastic. So every material we have, we can use a measuring tape. Okay, so this is used for long distances or long dimensions. So if you have to use for small dimensions, okay, we use a steel rule. Okay, so what is a steel rule? This is a steel rule. It is available in different dimensions, so it's up to from 150 millimeters up to 1000 millimeters. So it is mainly used to measure short dimension. It provides better accuracy than a measuring tape. Okay, so it is used to check flatness also, if the material is flat or not. Okay, it is used on wood, metals, or plastic. Okay, so these are the two most frequent measuring tools we have in a workshop. So then we have also some other measuring tools. For example, the external caliper. So, there are two models of external caliper. They are generally in metals. So they are used to measure external dimensions on bars or tubes. The dimensions is reported to a steel rule. So we measure, like here, we measure the thicknesses of materials or the diameters of materials. Okay, because a steel rule cannot measure diameter here. It's very difficult. Then the readings from the two tips of the caliper is transferred to a steel rule to measure the accurate, exact length of the materials. So it is used on wood, metal, or plastic. So every material we have. So we have also another type of caliper which is called an internal caliper. So it is used to measure internal diameters of tubes. Okay, the dimension is then reported into steel rules. So these are two models of internal calipers. So this is how we use an internal caliper. So the internal caliper is used on wood, metal, or plastic. Okay, so it's not a compass. It looks like a compass, but it's not a compass. It's called an internal caliper. Okay, so next we have as marking tools now. We have pencil. So the pencil is frequently used in the workshop to mark out damage when we are measuring, to make remarks or to write onto materials. We use a pencil. So a pencil used to mark on timber. It gives an opportunity to rub out any marking in case of mistakes. So on timber we use pencil because we can be erased afterwards. If we use for example a pen or a marker into timber, it won't be able to be raised afterwards. So it is used only for wood, only onto wood. Okay, so then we have on metals, we can use a scriber. Okay, it is used to make fine and semi-permanent markings on metal surfaces. So we scratch the metals with a scriber. This is a scriber. It is a very sharp, it has a very sharp tip here and here also. Okay, which is used to scratch and to mark out metals. For example, when using when using an engineer square to mark out a line onto metals, we use a scriber to mark out, to indent the metal. So it is used on metals, and we don't use it onto wood or plastic. So another types of marking tool is called a felt tip pen. So generally called a felt pen. So it's like a marker, okay? It is used to mark on plastic surfaces and also metals, okay? It provides a permanent marking, but we have to leave any scratch on the surface. So we don't leave any scratch, okay? So it's we write onto plastics or metals also. Then we have the marking gauge. So the marking gauge consists of a stock, okay? This is the stock, okay? This is called the stock, okay? Uh, and a stem, and it has also here a sharp uh, piece of material which is called a spur, okay. This is the marking part of the tool, okay. For example, here you can see when we rub the tool onto the material, it makes a small line, okay. So it is used to mark parallel lines to the face side of and face edge. For example, here you can see that on this edge, to mark a parallel line to this edge, we use a marking gauge, and it is used only onto wood, okay. Then another type of marking tool, we have a tri-square. So this is a tri-square is used only for wood, okay, and sometimes on plastic also. It is used to draw perpendicular lines during marking out processes, and it is used also to measure squareness. Squareness, that is the if a two parts are at 90 degrees. Okay, so during preparation of timber or assembly processes, we use a tri-square. So we have the tri-square is made up of a stock, okay, a wooden stock, a wooden stock, and a steel blade. It's not a cutting blade, but we call it a blade, okay. So it is different from the engineer square. So engineer square is used to mark perpendicular lines as the tri-square, or angles of 45 degrees. It is used to check squareness during assembly processes, but onto metals only. So this is the difference between a tri-square and an engineer square. It has the same shape, has the same purpose, but for metals and plastics also you can use it. So but the engineer square is made up of steel. The stock and the blade are all of steel. This is an engineer square also. The stock here and the blade are both are made of steel. So it is used to mark out 90 perpendicular lines as here, and 45 degrees, because in some cases for example here the engineer square uh, is cut at 45 degrees, so it can be used to mark out 45 degrees line onto metals or plastic. So there are also some other marking tools. For example, the center punch. The center punch is like a big nail. It looks like a big nail used to make an indentation on metals before drilling process. For example, when we have to drill, use a twist drill to make a hole into materials, we make a small punch onto the material here, a small indentation with a hammer before starting to drill, to avoid the drill from slipping. So it is used on metals or plastic, on metals only, sorry. Then we have a dot punch, which resembles the center punch, but it is used to dot scribe lines on metal workpieces before folding. For example, we can have, when we have to fold a piece of metal, for example, this is a sheet of metal, we make small dots, and we can then fold the material onto the dots we have made. So this is used using a hammer to make small, using a dot punch. We make small dots on a line before folding the material. So it is used on metals only. Okay, so here we are for marking tools. So we have also other types of tools. So the other family of tools is called the holding tools. So holding tools are used during different stages of the manufacturing process. Okay, so they are used to secure workpieces during different processes such as cutting, cutting out, planing, or drilling, and even measuring processes. We can use a holding tool to keep the workpiece in place when processing the material. So they are also used to clamp workpieces during joining operations. When using holding tools, it is always a good practice to use a piece of scrap material so as to protect the surface of the workpiece. So the jaws of the holding tools often exerts very a high pressure. It can indent or damage the material. So to avoid this damaging of materials when holding it, we use a scrap material. It may be a piece of wood or other materials which are we're throwing away. We put it between the teeth, the jaws, and the materials, and when we squeeze it, it doesn't damage our material we're working with. So it is called scrap material. Uh, Examples of holding tools. So we have first of all the bench vise. Okay, so a bench vise. So you see the bench vise, we generally use seen in the workshop, which it is fixed with the workbench. Okay, so a bench vise has a smooth flat jaws to prevent the workpiece from damaging. So the these are the jaws here and here. They are flat, and when we hold the material inside, it does not damage the material because it is flat. But as a precaution, we add here the this is the scrap material. We have a piece of wood we are throwing away between our material we are working with and the jaws, not to damage the material. So it is used to clamp wood workpieces during different processes such as cutting, planing, or chiseling. Okay, so it is used onto wood only. So another type of vise is called an engineer's vise. So this one is generally fixed on the top of of our workbench and is used for metals and plastics. Okay, the jaws is composed of grips, so it is not a flat jaw. There are grips inside here, grips for better holding of the material. It is used to hold workpieces during different processes such as cutting or filing. Okay, this provides secure working conditions for the user. So another example of holding tool is a machine vise. Okay, so this is a machine vise. Okay, it is used to hold workpieces during different processes such as drilling. Okay, the vise can be fixed onto machines such as a pillar drill using bolts and nuts. Okay, so it is used onto wood, metal, and even plastics. Okay, then we have the G clamp. So it is called G clamp because it has a G shape. It is used to hold different materials on the workbench. It is used during different processes such as joining or assembly. Okay, there are different sizes of G clamp, which is used onto wood, metals, or plastics. So another examples of holding tools, we have the F clamp. Okay, the F clamp has the same use as the G clamp. However, it differs in the shape. It has a wider opening. The G clamp is limited in the opening, okay, but the F clamp has a wider opening capacity. So this is the F clamp because it has an F shape. Okay, it is used to wood, metals, or plastics. Then we have the sash clamp. So the sash clamp is longer than the F clamp. Okay, it has a large it's used to clamp large workpieces. Okay, over 1 meter, 1.5 meters. It is mainly used during assembly processes. For example, when clamping a door, for example, when making a doorway table, we use long sash clamp to hold the material while they are glued together. So it is used onto wood, metals, or plastic. Then we have also the F, sorry, it's not the F clamp, it is called the corner clamps. Okay, it's not the F clamp, the corner clamps. So the corner clamps are used to hold workpieces at right angle during joining processes. As we can see, the materials are perfectly at right angle when they are joined together. So it is used onto wood and plastic, okay, not onto metals. We have also the bench hook. Okay, it is a simple tool which is made of wood, okay, which is clipped to the bench workbench, okay. uh, so it is used to hold wood workpieces while sawing or chiseling. So when we are sawing wood, we clamp the hold the material into the bench hook, and we can cut it. So it is used to wood only. In some cases onto plastics also, but very rarely. So other holding tools, we have the miter box. So the miter box is used to hold wood workpieces during cutting processes. So it enables the user to make accurate 45 degrees cuts. So this is a miter box. So the saw slides into the slots perfectly at 45 degrees to cut the wood at 45 degrees. So it is used onto wood. Okay. Sometimes there are some models used onto metals and some for plastic also, but generally it is used for wood cutting only. So then we have the pliers. Sometimes we call it pincers, but generally we call it pliers. They are used to hold and grip small workpiece during different processes such as drilling. It is available in different sizes and shapes. Okay, it is used for onto wood, metals, or plastics. Okay, so this is it. This is the first part of our lesson for tools in the workshop. So the next lesson will be about the driving and cutting tools. So stay tuned for the next lesson.